Sodium hydroxide was dissolved in water, then ethanol was added. This led to a very exothermic reaction, resulting in a sodium hydroxide solution.
Once the solution had cooled back down to room temperature, acetone and benzaldehyde were measured into a flask and added to the solution. The mixture will last for 15 to 30 minutes to ensure most molecules react. This reaction is what is known as the aldol reaction. The ethoxide acts as a base and removes the hydrogen off. The acetone formed an enolate with two resonance forms.
Because the oxygen on the aldehyde is more electronegative than the carbon, benzaldehyde is slightly polar. This makes the enolate, which is a nucleophile, attack the delta-positive carbon. Note that the negative charge is on the oxygen as it is more stable there, and moves down through the carbon to attack rather than the resonance form with the negative carbon attacking.
The negative charge on the second oxygen is removed by the addition of a hydrogen. The resulting molecule is known as an aldol. The second hydrogen on what was originally the enolate is also attacked on the basic OET-. This leads to a double bond formation. Although OH- is normally a very bad leaving group, under these conditions it is possible to make it leave, making the product an alkene. All of the steps above are repeated for the other side of the carbonyl group, leading to a final product that looks like this.
The product was filtered out of the solution by vacuum filtration and washed with cold water to remove excess alkali.
The crude product was dissolved in acetic acetate and dried using magnesium sulfate. Dried in this case means all the water molecules present were absorbed by the magnesium sulfate.
The solvent was removed using a rotary evaporator and the crude product weighed.
The crude product was recrystallized in the minimum amount of ethyl acetate, then isolated and dried using a vacuum filter.